Welcome to Skyway's web-based training series for IsatData Pro. This session will provide a high-level overview of an innovative solution we call IP-SCADA that enables the extension of supervisory control and data acquisition systems into small remote sites using robust, low-cost satellite communications technology. Skyway's IP-SCADA solution is really about three main concepts. 1. Plug and play. The solution connects directly to most common SCADA remote devices, such as remote terminal units, RTU, intelligent electronic devices, IED, or programmable logic controllers, PLC, using transparent serial communications. The SCADA master station connects to the network via a secure IP virtual private network, VPN, using common SCADA protocols encapsulated in TCP IP. 2. IP to serial translation. This solution effectively acts like a port server or bridge, using the network as the IP port and the IDP 600 series terminal as the serial port. IP to serial bridges are, in fact, commonly used in SCADA applications running over IP networks today. 3. Lower satellite cost by using less data. The satellite transmission part of the network uses minimal overhead compared to a conventional TCP IP implementation, which helps to reduce the recurring costs associated with satellite airtime. In some cases, this can result in up to 10 times data usage reduction compared to conventional TCP IP systems, such as 2G or 3G, cellular, or radio. It's also important to note, however, what IP-SCADA on IsatData Pro is not. It's not a generic TCP IP connection for the remote device. You cannot connect to a PC and run a web browser, for instance. It just transports serial data. It's also not a one-size-fits-all solution. The optimal data throughput for IsatData Pro compared to other satellite technologies is less than 50 kilobytes per month of raw data, which could equate to 100 kilobytes or more on a 2G, 3G system, but we'll talk more about that in a few minutes. Also, latency in the system is on the order of 30 to 60 seconds round trip. IDP IP-SCADA Overview. How it works is as follows. The SCADA master sends data, typically a pole, encapsulated in TCP IP over an IP PVN to a unique private IP address associated with an individual remote device. Skyway's IP-SCADA gateway maps the private IP address of the remote to an IsatData Pro mobile ID, removes the TCP IP overhead, adds a very small IsatData Pro overhead, and sends the data across the network. The IDP terminal receives the data, removes the IsatData Pro overhead, and forwards the original bytes on the serial port to the attached slave RTU. The slave RTU responds to the data pool with the requested data, which goes through this reverse process upstream to the SCADA master. The system also allows for the possibility of remote-initiated communications, sometimes called cryout, or unsolicited report by exception. In this case, the IP-SCADA gateway can be configured to open a session and push data to a listening server on the VPN. The IP VPN ensures secure connectivity for the user, while the IP to serial translation minimizes overhead costs. And the solution is totally transparent to the serial data going across. It could be Modbus, DMP3, ABB Total Flow, or virtually anything else that encapsulates serial data in TCP IP. In the system overview, we talked about master spooling slaves, a kind of question and answer model which is typically of many, if not most, SCADA systems. Modbus and DNP3 are examples of prevalent protocols used in different SCADA applications today, but there are others as well. Most SCADA protocols have been around for many years and have been designed to operate on many different forms of data transport. Typically, these protocols perform operations in a very small transaction of only a few bytes for each question and answer. For protocols like Modbus and DNP3, transport overhead can represent a significant portion of the overall data usage. For example, encapsulating an 8-byte Modbus RTU request in TCP IP adds 40 bytes of overhead plus a 40-byte TCP acknowledgement representing about 90% overhead per transaction. If there is an appreciable amount of time between transactions, for example polling once per hour, then on 2G or 3G networks the TCP session will typically be dropped in between transactions and result in a session rounding for billing purposes, up to the nearest 1 kilobyte or more. On IsatData Pro, we use only 3 bytes of overhead for a transaction size under 128 bytes, or 4 bytes overhead if the data is larger, with a minimum billable packet size of 15 bytes. This would represent more than 80% data savings for Modbus RTU compared to 2G or 3G systems. It is important to note that not all SCADA transactions are just tiny chunks of data, and larger SCADA packets mean smaller overhead contribution to total usage. An example could be a historical trend report from a flow meter, so it is important to understand your application to understand how much data saving you can reap from overhead reduction. There's also a multiplying effect of overhead per transaction for protocols like Modbus RTU related to the way data is accessed on the RTU. A typical RTU model has a map of various data register locations representing information such as sensor values or local clock. Let's look at a simple low-end RTU monitoring 6 digital inputs, temperature, and a timestamp associated with the measurement. The digital inputs will typically be grouped together as a group of binary data type. The temperature may be an integer or floating point value type from another register. The timestamp may consist of multiple registers to distinguish hour, minute, second, and so forth, which might be in adjacent registers, allowing them to be pulled as a group. Each location type or type of data requires an individual request, although those that are adjacent to each other can be grouped together for efficiency. Polling, this example RTU, then consists of 3 separate Modbus requests and 3 responses with total raw data requirements of 54 bytes. Encapsulated in TCP IP, the total usage is 375 bytes, which if polled every hour likely gets rounded up to 1 kilobyte per hour. IP-SCADA over IDP would use 95 bytes for the same set of transactions, resulting in between 75% to 90% total data reduction. Other protocols may manage data more efficiently, so it's likely that Modbus represents the most extreme case of potential bandwidth savings with IP-SCADA from Skywave. However, when talking to the end user, the metric for how much capacity do you need may need additional questions to understand what protocol or protocols their remote devices are using to give an indication of potential economic fit for IsatData Pro. IsatData Pro IP-SCADA and BGAN-M2M are complementary technologies with different target applications. For SCADA, in most cases the decision between the two is based on the application requirements. This tends to be qualified in terms of polling interval or data refresh rate, and recall depends on how many different parameters are being polled. A good rule of thumb is that polling once per hour or less frequently may be a good candidate for IsatData Pro. Keep in mind that while IsatData Pro is suitable for SCADA applications using serial data, BGAN-M2M allows generic background IP such as web browsing, FTP, and other services. Although many modern RTU devices now have available Ethernet ports, many do not and can plug directly into the IDP terminal using its serial port. For RTU without Ethernet ports, an additional IP to serial adapter may be required for BGAN-M2M. The typical price range for these devices is from $50 to $500. IsatData Pro is best suited to applications that either poll infrequently for data or use exception-based reports to minimize data cost, and we typically quantify this on 1 order of kilobytes per month. Applications requiring higher throughput, such as kilobits per second, are better suited to BGAN-M2M. IsatData Pro should also be considered in applications with extremely tight power constraints, typically when running from battery for extended periods of time. However, ultra-low power optimization also trades off against data refresh rate, so applications requiring sub-second latency tend to be better suited for BGAN. Finally, the IDP solution can be customized to do more than just transparent serial data, such as out-of-band communications or avoiding deployment of an RTU to manage simple sensors and controls, which can save several hundreds of dollars. Talk to your Skyway representative to find out more. In terms of value proposition, we have already discussed the notion of plug and play, making it an easy fit with existing SCADA systems where the remote device uses serial communications. The economic sweet spot for IDP in this application is likely somewhere under 100 kilobytes per month compared to conventional TCP IP to G3G usage. But there are other benefits of the IsatData Pro solution as well. IsatData Pro runs on the Inmarsat I4 constellation using L-band regional beams. This means a few things. First, customers can standardize on a single technology for low data rate communications around the world, simplifying planning and inventory management relative to cellular systems or diverse satellite systems. Secondly, no worry about weather impacts from rain, snow, sleet, hail, and so forth. L-band is one of the most robust communications around. Third, geostationary means the satellites don't move, so once you have a valid satellite link, it will be there giving consistent performance all day, every day. IDP terminals have a highly compact footprint, including an omnidirectional antenna. This greatly simplifies and speeds up installation, since there is almost never a need to point the unit to the optimized signal, though the option still exists. The small footprint also has a number of subtle side effects that can save significant installation costs, such as reduced need for elaborate footings, or wind bracing, or seismic movement. Additionally, the terminal is fully environmentally protected. It operates from -40 to +85 Celsius. IDP terminals operate over a wide power supply range and run very low power consumption, milliwatts, even when configured for always on. Additional power savings are possible by fine-tuning some settings and coordinating polling intervals to reduce by an order of magnitude for battery-powered installations. Lower power demands result in a number of related cost benefits, such as smaller batteries that last longer, smaller panels that recharge those batteries, and smaller installation footprint to support both batteries and solar panels. Skywave also has available a Class 1 Division 2 Group A/B/C/D terminal variant suitable for safe operation in certain hazardous environments. Finally, we have simple bracket and cable accessories available from Skywave to quickly assemble installation kits for deploying to the field. And that concludes our presentation. Thank you for your time. We hope you found this training module informative and helpful. If you have any additional questions, please contact Skywave Sales or Skywave Support. Thank you.